Hi, my name is Kyle Haley. I'm the Principal Product Manager for an RDS feature called Performance Insights. So I'm excited today to introduce Performance Insights, the cloud-based performance monitoring for databases. What is Performance Insights? Over the years at RDS, we've gotten a lot of great feedback for our automated features, such as backups, upgrades, HADR, point-in-time recovery. But one thing that's been asked for by customers is visibility into performance of RDS databases. Customers want to optimize their cloud database workloads, and they want a tool that's easy to use. Sometimes they have only a part-time DBA, sometimes there's no DBA at all. So it's important that the tool be easy. And they want it in a single pane of glass, a one-stop place to go and get this information. Our first step was 2 years ago with the release of a feature called RDS Enhanced Monitoring. RDS Enhanced Monitoring concentrated on the OS statistics for RDS databases. A couple of good aspects of this feature were it had up to 1 second granularity, so very fine-grained collection of metrics optionally, and it has a feature called the process thread list, which is like the Unix top command, so providing insights into the processes running on the host that's supporting the RDS database. Now, this concentrated basically on the operating system. The next step, and what we're introducing now, is Performance Insights, which concentrates squarely on the database, what's actually happening to the load on the database. So Performance Insights presents a dashboard, and in that dashboard, we present database load over a time series. It's an adjustable time frame, and that load is filterable by different attributes, such as SQL, user, host, weights. And in that dashboard, we identify which SQL are causing the load on the database. And the feature is a phased delivery for RDS databases. We released last year on Aurora PostgreSQL, and we will be releasing soon on Aurora MySQL, to be followed by RDS MySQL, RDS MariaDB, then RDS PostgreSQL, and finally the commercial engines, RDS SQL Server and RDS Oracle. When we created the dashboard, we designed it to provide a guided discovery of performance problems. We want it to be interactive and let people explore situations. So the dashboard is both for beginners and experts. And it's based on a core metric called database load. Now, what is database load? Well, first of all, unlike many monitoring systems in the industry that show maybe 10 graphs or 20 graphs or more of metrics in time series, that the user has to correlate and understand and maybe aggregate in their mind to figure out what's going on, we wanted to simplify database load. So we boil it down to a single metric. Now, where does that metric come from? All the RDS database engines have a structure internally that shows the connections to the database. And for those connections, it shows which connections are active and which connections are idle. And what we do in Performance Insights is we sample that structure every second. Now, doing some activity on a database every second might sound like a high load activity, but actually this activity is extremely lightweight. As we're just sampling, we're just reading some memory. It's already in memory, there's no read off of disk, and it's very fast. In our testing, it's about 1% of one core on the host. So for each of these connections that are active, we collect which SQL that connection's running, what state that SQL's in. Is that SQL running on the CPU, or is it waiting for I/O, reads from disk, or maybe waiting for a lock, or maybe waiting for a commit to log wait, or other internal database resources. We also collect which host the query is coming from and which user is executing that query. Then we aggregate this data and expose it as a metric called average active sessions, which we also call AAS. Here's the Performance Insights dashboard. It's divided into two parts. The top part shows the load on the database over time, and the bottom shows the top SQL in that time frame, ranked by which SQL are putting the most load on the database. We see in the interface that there's some options. In the top right, we can pick different time frames. By default, we show a 1 hour time frame, but we can click down to 5 minutes or out to 24 hours. Also, the graph is interactive. So we can click and drag our mouse and zoom in on any time frame we want that we can see in the graph. To the right of the top graph is the weights on the database. One thing great about this feature is that the interface will be the same across all the RDS databases. It'll look exactly the same. The only difference will be that the weight names will differ by different database engines, but they basically map to the same kind of internal database activities. And we'll go into this in more detail. Now, when I pass my mouse over the load in the load chart, the database load chart, I'll see in the legend the actual values of average active session for each of the components. And the total is at the top right of the legend. Then on the bottom, I have the top SQL, ordered by how much load they're putting on the database. And the bar that shows the load on the database shows in average active sessions what that load is on the database. And it's color coded to the weight events that we see in the top graph, the database load graph. Let's talk a little bit about how we collect this data. So we collect this data via sampling. So every second, we collect who's active and different information about those active connections. So here I have time running from left to right, and I have 3 users with 3 different timelines running left to right. Then I have these vertical lines that represent when we sample, when we come along and see what the activity is on the database. Now, this can be a little bit unsettling, as in between sampling, I don't know what's happening. We do miss data. But let's look at what happens. In this example, I have 3 different queries run by these different users. The first query is a fast query that's not run very often, and it's represented by this light green rectangle. The second query is a little bit slower, but still fast, and it's run more often. And finally, you have a slow query that's multiple seconds. So what we see is that any query that takes more than a second, like the slow query, will always capture it, since we're coming in every second. For the really fast query that's not run very often, we might completely miss it. We might catch it once in a while, but for the most part, we're missing it. And then for the query that's run very often, we'll miss it sometimes and catch it sometimes. And what happens is we end up filtering out the noise. So the fast query that's not run very often really doesn't have any impact on the database. It's already optimized, and it's not putting any load on the database. So we can filter it out when we come to look at what's putting load on the database. Whereas the query that's run very often, but it's fast as well, it is putting some load on the database, and we'll see that. And finally, for any slow query, we'll always capture those. And this is a little bit like a film. When we go see a film, it looks seamless. I don't see any missing data, but actually there's 24 frames a second. And what happens between the frames, we're missing. And we find that sampling once a second on the database provides us with a seamless view of what's happening in the database. So how do we expose this graphically? So we come in and we sample every second, and what we're seeing is which users are active and when they're active. So here I have a timeline running left to right with 4 users, and then I have these green rectangles. The green rectangles represent when I'm running a query. So when a query comes into a connection, the green rectangle starts, the database starts processing that query, and then it returns results to the user, and that rectangle ends. So here I can see at a glance what kind of activity is happening on the database, how much load there is. And what we do graphically in the dashboard is we basically just stack that activity. Now this gives us a clear view of the concurrency of activity on the database, which gives us a view into how loaded the database is. But we've just been talking about active versus idle, but we can get more information than this. So here I have a single connection, it's idle, then it runs a query for some time, then it's idle again, runs another query. And that gives us a good view of the load on the database, but we can get a lot more information out of it. So if I look at the same connection, but here I've color-coded the actual activity by different states. So green is CPU, when the query is running on the CPU, or trying to run on the CPU. Blue is when it's waiting for reads from storage. And then the orange is a wait, where it's waiting for some database resource, such as a lock or a latch, or some internal buffer. So for the first query, it comes in, and we start running on the CPU, and we continue to run on the CPU the whole time until the result set's returned to the user. The second query, we come in and run some CPU. Then we have to wait for some I/O off disk to get some more of the data to process, run some more CPU, and then we return our result set. And in the third query, we come in and run on CPU. Then we have to wait for some internal database resource. Once we get the resource, we start running on CPU again. Then we wait for some other database resource again, and then finally run some CPU and return our result set. So if we take our graphical load, concurrency load, now we can color code it. So not only do we see how much concurrency there is in the database, but we can see the states of that concurrency. Now, when I see a graph like this, one question I immediately have is that load big or small? can I ignore it, or do I have to, there's something important going on here? And there's an important yardstick that we add to the dashboard. So now I can see the load, not just by current activity, but I can see what state that activity is in. And this tells me what kind of load is on the database. So here I see that I spend about a third of my time on CPU. I'm also spending maybe another third, or close to a third, waiting for I/O, and then finally some waits. Now, in Performance Insights, we collect the data every second. So if we displayed every second, we'd get a very fine-grained looking graph like this that might be hard to read. So by default, what we do in Performance Insights is we bucket the activity into average active sessions over 1 minute buckets when we come into the 1 hour graph. You can actually get the single second sampling if you zoom into the 5 minute, or if you click and drag your mouse to a small minute interval, you'll see the actual single seconds. But by default, we just show the average active session by 1 minute buckets. Now, when I see something like this, my question is this a big load or a small load on the database? And there's one important yardstick that we use to determine that. I mean, is this the kind of load that I can ignore, or is this something I need to jump on and look at? And that yardstick is the max CPU. And this is a dashed line in the dashboard that shows the number of cores on the box. And to start with, we can only have as many concurrent sessions or connections on the database running on the CPU as there are cores on the box. So if I have, in this example, I have 2 cores on the box, but the green, which represents demand for CPU, goes up to above 3. So for example, if I have 3 sessions that all want to run on CPU, but only have 2 CPUs, then at any one point in time, one of those connections is waiting. So this graph quickly shows me that there's CPU saturation on this database. And on top of that, I can see the database is pretty heavily loaded. Whenever the load goes above the number of CPU cores, then we know that people are waiting. They might be waiting for CPU, or they're waiting for some other resource. And in this case, by the color coding, we can see that we're also waiting on I/O and also waiting on some wait events. So let's talk a little bit about this metric, average active session, or AAS. Now that we see what AAS is, the average active sessions, and we see our yardstick, the number of CPU cores, we can come up with a list of heuristics that we can use. The first is, whenever AAS is less than 1, we know that the database is not blocked. In order to have a blocked database, I need at least one session that's not making any progress. If I have one session that's not making any progress, I have at least one active session, or one average active session. Then when AS is near 0, this means that the database is idle. And this is important. There's been many times in my career where I have the application group or the users call me and say that the database is slow or the database is blocked. And in the past, it's been difficult to communicate to users or application groups that it's not the database in certain cases. And now with AES, I can quickly and clearly show when it's not the database. So when AES is 0 and the users or the application team says there's a problem in the database, I can respond and clearly show that the problem is not the database. The database is idle. The problem is coming either from the application tier or maybe the connection tier to the database. Then the third point here, when AES is less than the number of CPUs on the box, we know that there's CPU available. In RDS, there's only one database running per machine. So when AES from the database is less than the number of CPUs, there's CPU available on the machines. The machine is not blocked. But whenever AES is greater than 1, there could be a single session blocked, and that would take a little bit more analysis. When AES is greater than the number of CPUs on the machine, this is the territory where we start seeing some performance problems. And finally, when AES is much, much greater than the CPUs, we know there's some sort of bottleneck, and we're going to want to analyze and see what's happening on that database. So when users say the database is slow, now we can come into Performance Insights dashboard. And if it looks like this, we know it's not the database. In this dashboard here, it's empty. Now I've put in text that says AES equals 0, otherwise it's empty. So there's no load on this database. So when people see a slowdown, it's coming from outside the database. So now it's quick and easy to prove that it's not the database. And this is important because this allows us to know where we want to concentrate our efforts in researching the issues. And it might help us avoid meetings and discussions and arguments where people are trying to figure out where it comes from. Now we can quickly help guide our efforts. AES is also useful for sizing. So in this first graph here, I have an average active sessions that's almost all on green or CPU, and it's very small compared to the machine. This machine has 16 cores on it. If this is the steady state of the database, and the load really never goes above this amount, I know that this instance is oversized, this host is oversized for this database. So I could save some money and put it on a smaller instance size. On the other hand, if the load is greater than the number of CPUs, then the instance is undersized. Here I have a case where the spikes are constantly going above the max CPU. The max CPU is 2, and our spikes are spiking up over 6, and it's green, which is demand for CPU. So if I put this workload on a larger instance class, it would run faster. Now, how do we access performance insights? Here I'm in the RDS dashboard, and there's two ways to access performance insights. On the left, there's a new menu labeled Performance Insights, and if I click on this, I'll be brought to a list of instances that have performance insights enabled. And I'll be able to click on one of those and go to the dashboard for that instance. The other option is, and I want to bring your attention to, is the last column here called Current Activity. Now, when Performance Insights is enabled on the database, the Current Activity column will report the number of active sessions. So we see sessions as the unit. Rectangle is empty, it means the database is idle. When there's blue in it, it means that there's load on the database. And when the blue turns to red, we know that the database is overloaded. There's a little red line to the right end of the rectangle, and that represents the number of cores on the database host. So when the load goes above that number of cores, then the widget starts to turn red. The more red we see, the more of a bottleneck. So here's an example of a dashboard where I have an instance that has a lot of red. So there's some sort of bottleneck going on this instance. So here I can just click on that widget, and it'll take me directly to the dashboard for that instance. So let's look at some use cases. So the first use case is a CPU bottleneck. So I've clicked in the dashboard on the widget, and it takes me to the dashboard. So here's the Performance Insights dashboard, and we can look at and see where our load's coming from by the legend on the top right. So these are the different wait states. So CPUs, when we're running on the CPU, and everything else is something that we're waiting for. In this case, what are we waiting for? We see that spike to the right side of the database load chart, and we can see in the legend that it's CPU. Now we can compare that to the max CPU, and we see it's much greater than the max CPU. So here we have some sort of bottleneck. And that bottleneck is this high load in the section circled here. Now, it's where we're seeing CPU demand greater than the number of cores. So in this case, we know that we have CPU starvation. So what do? We can move this, we could migrate this instance to migrate this database to a larger instance class, but that would cost us more money and might take some time and planning. So as a DBA or a developer, instead, I can try to optimize the application. Now I can get some more information by just dragging my mouse across that spike and releasing it, and then I'll drill down into that actual period of problems. So in this period of problems, I can see there's only one SQL statement that's really burning CPU, and that's that first SQL statement, select minute rollups, which is actually a function. So if I eliminated all the other SQL running right now, it still wouldn't gain me back enough CPU. So my only choice, the only place I need to put my efforts is in that one function. And if I can optimize this function, I might be able to get back enough CPU so that we're running under the max CPU line. Let's look at a second use case, a wait bottleneck. So here I have the dashboard, and I see a different configuration. It's similar. I see a spike in the middle to the right of the DB load chart, but instead of being green, now we have this light orange color. So again, I can click my mouse, drag it across and release, and I'll zoom into that bottleneck. Now I can see that this is light orange. I can look in the legend and see that the wait event here is IO:XATT sync. Now that name itself is not that informative to me, but what we can do is leave our mouse over the label for a second, and it'll pop up documentation. It'll explain what the wait event is, and in some cases give me insights into what to do to optimize that situation. So a quick summary of this wait event is we're waiting for commits to stable storage. And this can happen when we do commits. And in this case, we're using Aurora Postgres SQL, and by default, it has implicit commits. And if I look down at the top SQL, I can see that the one SQL statement that's really putting this load on the database is this insert into authors, and I see 3 fields and then values and 3 values. This is basically a 1-row insert. And what happens is I insert and then I have to wait for a commit to stable storage, and then I can do another insert. So this is all those waits for the commit to stable storage are slowing down these insert statements. So what we can do is instead insert multiple rows at a time, maybe 50 or 100 depending on what my options are, and that will reduce the wait for this wait event. So far we've been talking about the default layout of the dashboard, but the dashboard has options to look at the data from other dimensions and other groupings. So on the top right in the legend for the DB load, it says slice by weights. So weights are the default way that we group data in the load chart. Next to it, there's a downward pointing caret. So if I click on that caret, I'll get the other dimensions that I can group data by. So I can group data by SQL, host, or users. In this case, I'm going to choose SQL. And what we see, this is the exact same load on the database. The only thing that's changed is the grouping of those colors. So whereas before the colors represented weights states, now we're seeing which SQL are putting the load on the database over time. So there's 2 spikes on this graph, one in the middle and one to the right. And I can see during those spikes, there's really one SQL statement that's making the load spike, and that's that insert into authors. Now on this bottom of the dashboard, I've also chosen a different dimension. By default, it's top SQL, but we also can do by top weight, or top host, or top users. And in this case, I've chosen host. And this can be really interesting. Often we have a set of hosts for the application servers that connect to the database, and we want to balance our load across those application servers. And typically those application servers have the same code running on them. And so what I would expect is the same amount of load on each of the application servers and the same profile of the load, same type of load. Now, if I look at these servers, they have about the same load on them, just a little over 1 AAS, but the load profile is completely different. The bottom server is only running that one SQL statement, that insert into authors. And the top host is running a bunch of different SQL statements that aren't being run on the first host. So here I can see that something's different. Maybe my rollout of code to the application servers didn't go correctly, and one application server has the wrong set of code, or my load balancing isn't working correctly. So this is a good way to verify how the load is balanced across my application servers. So now let's do a quick live demo of some of the things that we've seen in these slides. So here I'm in the RDS dashboard, and there's 2 ways to access Performance Insights. One, I can click on this new menu item, Performance Insights, and I'll see a list of the databases that have Performance Insights enabled. The other way is by looking at our instance listing. And what I want to bring your attention to is the current activity column. For those instances that have Performance Insights enabled, the current activity will be measured in sessions. So I have 5 databases I can see here that have Performance Insights enabled. And one of those has high load. We can see that quickly visually with this rectangle. The rectangle, if it's empty, means the database is idle. If it has blue, there's some load. And if it has red, then there's some sort of bottleneck. And I can simply, if I see some red, I can scan the list quickly, find anybody that has red, click on it, and go into the dashboard and see what's happening. So in this case, I can see that there's some heavy load coming in on the right of the database load chart. There's also some load on the left-hand side. Now, if I want to investigate what's happening right now, I can just click and drag my mouse, and I'll zoom into that area. And I can see what's happening by the color coding. So the top right, I have my legend. I see CPU is green. So this is all CPU load for the most part. Now, where's that load coming from? I can look down at the bottom, at the top SQL. I can see almost all that CPU load is coming from that first statement. Select minute rollups. And then we can look at different time frames, down to 5 minutes, and I'll see per second samples. I can zoom out to 5 hours, or 24 hours. And during the 24 hours, I can start to see patterns. I can see these different kind of spikes. So we've just looked at the green spike, the CPU spike, but there's this other, that light orange spike. And what I can do is, in order to investigate it, I can just click and drag my mouse again, and that will zoom into that bottleneck. And I can keep drilling down and farther and see exactly what's happening in that bottleneck. In this case, it's this light orange. I can see my wait event, IO:xact sync. If I leave my mouse over that wait event, I'll get some description of what's happening and what actions to take. In this case, we're waiting for writes to stable storage, and we can see where that's coming from. All that load's coming from the first insert statement. The text told us in order to optimize that, instead of doing small inserts like single row inserts, we can do multi-row inserts so that we're not waiting after every insert statement for that writes to stable storage. I'm going to go back to 1 hour time frame. And we can look at this data by different dimensions. So in the legend for the DB load chart, the top right, it says slice by weights. So weights is the default, and we think that's the most powerful view of the load on the database. Immediately I can see how healthy the database is. Typically want to see most of our time on CPU. If we're spending a lot of our time not on CPU, those represent bottlenecks that can be optimized or eliminated. But I might want to look at the load from a different perspective. So there's this caret next to slice by weights. I click on it, and I have a pull down that shows me the other dimensions, such as SQL, host, and users. In this case, let's try another one like SQL. So now the total load is exactly the same. All we're doing is changing how we group the load. So before we were grouping by weights, now we're grouping by SQL statements. And I can see some interesting patterns. I can see during the spikes, there's a new SQL statement that wasn't being run otherwise. That's now putting a lot of load on the system. Now, when I change the dimensions on the top chart, that'll change how the load's displayed in the bottom. So now instead of seeing load by weights in the load by SQL column, I now see it color-coded to the SQL statements. So now it's one-to-one, mapping a SQL to SQL, so they all just have one color. But I can choose other dimensions on the bottom as well. I can choose weights and see the top weights by SQL statement, or I can see the hosts. And now this is really where it gets interesting. Typically, the hosts are application servers. So we deploy the same code across the application servers and then load balance our load across those application servers. So I'd expect the load across those application servers to be the same, and I also expect those application servers to be doing the same kind of work. But here I can see quickly that no, they're not running the same kind of work. The first one's running, looks like just one SQL statement for the most part, and the other one's running a set of different SQL statements completely. Finally, we have this last row that says local. Local is things that are run on the host, like internal process of the database. So this, in the case of PostgreSQL, this could be a vacuum process or something. So it's not putting much load on the database. So that's a quick view of the interface live. And now we'll go back to the slides. So final word, I want to talk a little bit about the architecture because it's really interesting and shows some of the power of the feature. The feature is fully automated. All it takes is clicking a checkbox in the creation wizard or modify wizard for a database instance, or using the API as simply a flag. And after that, we don't have to do anything. It's fully automated. All the storage, collection, display is handled automatically. The agent that collects the data is lightweight. In our measurements, it takes about 1% of 1 core on the box. And then the data is taken off the box and stored in AWS native services. That data is encrypted both in flight and on storage, and it's using the customer's encryption keys. And what's interesting too is for most monitoring tools, the performance data is inside the database. So when a monitoring tool connects to a database, it has to actually demand work. Give me this data from the database and supply it out to the monitoring tool. And if a bunch of DBAs jump onto a problem, that can put actually a lot of load on the database being monitored. In the case of Performance Insights, there's no impact at all. All that data is coming from storage and AWS services. I could have 100 DBAs hop on, look at the dashboard, and it would have no impact on the database that we're monitoring. So finally, release information. What's available at launch? Well, our first release was on Aurora PostgreSQL. And with that release came the database load chart. This shows the database load that we can slice by different attributes with adjustable time frame from 5 minutes to 1 day. We have the different dimensions of weight, user, host, and SQL. And we can zoom into anything on the load chart. Just click and drag the mouse and release, and we zoom on into that area. We have the top in table, which is top SQL by default. But we can also look at top weights, top users, or top hosts. What's coming soon is a public API and SDK. So we can, as a customer, you can collect the data directly and hook it into your own monitoring tools. We'll be adding metric charts. So in the dashboard, we'll have optional charts where we can chart database statistics and metrics and OS metrics. such as for database, it might be transactions a second, IOPS per second. OS, it could be paging a second, CPU percentage. We'll be adding SQL plan. Right now in the interface, there's just the SQL text, but we'll be adding the SQL execution plan as well. We'll be adding alerting, and this will be done by egressing data to CloudWatch and leveraging the alerts from CloudWatch. Then we'll be rolling out Performance Insights across all the RDS databases. Starting first, after Aurora Postgres, which has already been released, we'll be launching on Aurora MySQL, to be followed by RDS MySQL, RDS MariaDB, then RDS Postgres, and finally the commercial engines, RDS Oracle, and RDS SQL Server. To the top SQL table, we'll be adding stats. Right now, we just see the load on the database, which is probably the most important first metric to show. And then we'll be adding executes per second, elapsed time per SQL statement. And finally, we'll be adding the option for long-term data retention. Right now, it comes by default with 24 hours, but we'll be adding the option to have a long-term data retention in the 24 hours. So in summary, what we've seen, Amazon RDS Performance Insights shows the database load using the metric average active sessions. This easily and powerfully identifies bottlenecks on the database. And if we see a bottleneck, we can look at the top SQL table to identify the source of those bottlenecks. And the interface enables problem discovery. We have adjustable timeframes such as minute, hour, day. We also have the different dimensions we can explore and aggregate the data by. If you have any questions outside of this webinar, you can contact us at rdspi@amazon.com. Thank you for joining us today.